Given probability mass function for the random variable x, where x takes on the value 1 with probability 0.7, the value 2 with probability 0.2, and the value 3 with probability 0.1, the goal is create a function that will output effective random draws from this PMF. Okay, so the first thing I want to point out is that you'll notice in the title of this video and in the slide that I'm saying it's an effective random draw, and that's because it's not truly random, it's based on time. As you can see, I've imported the time module here, and I'm using the time function to help get our randomness in this. And then what is the this time.time function here? Here's an example of this function, a random draw. And this value here is going to be the time since the fixed date. Now you can calculate what that is yourself, but I think it's maybe January 1, 1970 or something like that. Anyways, it's a long time ago. It's not really important exactly when that date is. It's just a fixed date, and this gives us the number of seconds that have passed since that fixed date. Okay, so what we're going to do is then b is assigned to the integer value of a, so that's just this here. C is the difference, so it'll pick out the decimal, just with a lot more accuracy, a lot more digits here. D is assigned to the string of this decimal value here, and then we create a list with the string of this. That's just so that we can use list indexing. And I've assigned crit val, meaning critical value, because it's the value that determines what the random draw will be, to the integer of this list indexed at 0. Remember, there's only one item in the list, so it'll pick out this, but we'll be able to further index it, and I've chosen 10 here. So what that's going to do, remember, indexing in Python starts at 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's your 4. So it's picking out this digit. Now, why is that considered random? Well, if you think about it, if we had a running clock from that fixed point in time, and even if we could see that running clock, the digits out here, because remember this is in seconds, it would be running so fast that it would be virtually impossible to control what that digit would be just from running this function. No, I've chosen 10 here, but we could easily have chosen something a lot less, and it still would have been pretty much as accurate and as random, because even if we were to choose this is index position 5. So if we changed this 10 here to a 5, it would still be tenths, hundredths, thousandths, 10,000ths of a second here. So that would still be going extremely fast and still extremely hard to control what value we would get. But I just chose 10 just because it would be, I guess a little bit harder to control as we get out here, and therefore seem a little more random, but even 5 would be more than enough. 10 is just overdoing it a bit. Anyways, why would we consider this digit here to be random? Besides the fact that it's going so quickly, well, we could also see that it's if it's going so quickly and it's going to be the same amount of time that this digit would be a 4, that it would be a 5, a 6, or any of the other digits, and then it would just keep repeating those digits. Because it would be the same amount of time, we would expect to see this this digit here as uniformly distributed between the 10 digits, the 10 possible digits we could get. And once we know that, it's fairly simple to get a random draw from the distribution we wanted. Remember, it's a ratio of 7 to 2 to 1 for the 1, 2, and 3. So we have 10 digits here, and it's uniformly distributed between those 10 digits. So if we choose 2 of the digits, I've picked 8 and 9, that would give us the 20% for a random draw of 2. One of the digits would give us a random draw of 3, and the rest would give us the random draw of 1. And that would give us the 7 to 2 to 1 ratio that we're looking for. But again, it's just, we could choose any two digits here to get started for a random draw of 2. I've chosen 8 and 9, but you could have chosen, 1 and 7 or 2 and 6 or any of the two digits. Just make sure you're not repeating the digits. When we assign to 3, we don't want it to be an 8 or a 9. So I've chosen 0 here, and then the else will take care of the rest. So yeah, so that's why this is going to give us an effective random draw. I've already put this function into Python here 10 times. So if we just run them, we'll get 10 random draws here. So let's just see what we get. Okay, so we got, let's see here. Oh, and another thing I want to point out is you can see that since it was just a few seconds between running this function, you'll see that the times since that fixed point in time is going to just change by a few seconds, not the example, but here 5363, 5366, 5368. So you can see it's just moving by a few seconds. As for the draw itself, we got 1 how many times? 1, 2, 3, 4, 5, 6, 7, 8. 8 times, and we got a random draw of 2 twice. So we didn't get the 3, but again, that's just because this here, it's only when that digit is a 0. So we only expect that to happen 1/10 of the time. So it's not really a big surprise that we didn't get the 3. And actually getting a ratio, I guess, of 8 to 2 to 0 is pretty similar to the 7 to 2 to 1. So yeah, that's all for this video. I hope you found it helpful, and thanks for watching.